This conference will now be recorded.
Welcome everyone to the workshop on cloud performance engineering in DevOps. Today we're going to talk about database reliability in the cloud. Uh, what are different services? I request everybody to be on mute. I'm getting a noise. Thank you. You can unmute yourself if you have any questions. Uh, yeah, that's perfectly fine. Okay, so this is the workshop on the cloud database reliability to understand what do we the database we know, right? We can have in on-premise as well as in the cloud. So what are different database services that we have in the cloud, particularly in AWS? We'll talk about that and how it ensures the reliability, availability, right, performance. So we'll talk about these things, right, in the workshop. So before I get started, let me introduce myself, everybody. This is Roshan. I have overall 17 years of experience in IT. Uh, Started my career as a Java developer, then I've been into performance engineering, into various DevOps consultant role, SRE and DevOps consultant role. Been into cloud from last 6 years, 7 years, I would say, yeah, 7 years. Into Kubernetes, Docker, containerization completely from last 6 years. I've been into automation using Terraform, Ansible, Jenkins, shell scripting, Python. Have been doing that. I'm associated with one of the reputed retail giants in the world that we have. I'm the DevOps and SRE consultant there, and I'm with Isha from last 4 years. Yeah, and I have been teaching from last 6 years, and that's my hobby to share my knowledge. That's about me. Okay, so we'll get started, guys. I hope everybody can hear me just fine. I'm audible, loud enough, and everybody can see my screen.
Yes.
Um, Perfect. Thank you. So, okay, so when we talk about database cloud, so first of all, let's understand the basic functionality. What it is that we are talking about here. So see, we have databases. If you talk about databases, primarily we have two kinds of DBs, right? We have relational and non-relational, NoSQL databases. Earlier, in most of the architecture, we were using relational databases. Still, we are using, but it's not like we cannot go away completely with NoSQL. But mostly nowadays, if you see any architecture, could be Netflix, whatever, Hotstar, any application that we use on daily basis, Swiggy, Uber, right? We would see in the architecture, if you deep dive, we'll see that they're using mostly NoSQL, right? Non-relational databases like DynamoDB, MongoDB, Cassandra, right? Those databases they use. So how are they using it? Are they using on-premise? So when we say on-premise and the cloud, so first of all, we need to understand the difference. What is the difference between on-premise and the cloud? Can anybody would like to? We'll just touch brief. Okay, this is from the scratch. I'll try to cover for the people those who have no idea about cloud and on-premise. So we'll just touch base and then we'll continue from there. Anybody would like to tell what is the difference between on-premise and the cloud? Nobody? Do we know? Or shall I go ahead? Okay. So silence. I'll take it. You can use the chat option, guys. Okay. Anyway, so let me go over it. Okay. So when we say on-premise, I'll start with here. Okay. So this is a data center looks like, right? This is a typical data center. Consider a multi-story building in the outskirts of a city, and all the halls, rooms full of these servers. It's a That's called a data center. So whether who owns it, whether the company where you work or the customer owns this data center or somebody else, that defines you're using on-premise or cloud. So let's say if you're working in a company like IBM, Oracle, they have their own data centers, right? So you can say that, okay, I'm working on on-premise. See, it doesn't matter from the infrastructure perspective. On-premise or cloud doesn't matter. It's the same data center, same servers, right? That would be the similar infrastructure. It's a very costly affair. Setting up your on-premise is a very costly. Look at this, one of the Meta. You can see this. It's a very costly affair. Outskirt of the city, multiple acres of land. You need to procure. You need to construct building, purchase all these servers. These servers will generate heat. You need to take care of the cooling mechanism. These servers, so many servers, cannot run out of power. You need to have multiple power sources, network. So a lot of investment, billions of dollars goes into investment of a data center. Not everybody can afford that, right? Earlier, there was no option. When earlier, when I say around 20 years back, if it go, if anybody has any business idea, like let's say Amazon.com, or those applications you can think of, Google.com, or any popular websites that you have been using. So they had their own data centers, and then they procured all the servers, they deployed the application, and we are using it. So we are hitting the servers which is deployed here, and we're able to handle requests. So that's a data center. So if you own it, or the company where you work owns it, that means you're in on-premise. But if you use someone else data center like AWS, Amazon Web Services, Azure, uh, GCP, Google Cloud Platform. So if you use someone else, so like a rent basis, like how we stay on rent, we can enjoy the stay as long as we pay the rent, right? Same thing goes with the servers. You pay the bill, you can use AWS servers. You can use those servers for storage, for deploying your applications, whatever regions you can use them as long as you pay the monthly bill, and it feels like you own it, but actually you don't own it. They own it, and we basically use it for rent. We call it pay as you go. So that's the basic difference between on-premise and cloud. Are we clear? Please give me a thumbs up uh, on the on-premise and cloud definition part. So bottom line is, it doesn't matter. Infrastructure wise, it remains the same whether you own it or you don't own it. If you rent it, that's cloud. Good. So if you, let's go to one of the cloud. Let's log in. Guys, are we good? Please give me a thumbs up or say yes in the chat. I can proceed. Okay, thank you for the confirmation. I'm logging to one of the cloud consoles. See, so now let's say I want to use a cloud. Today I decided. So I have a business idea. Think about, let's say I make my trip or Swiggy kind application I'm trying to develop. Let's say I have a business idea. I know I have some developers who has written the code, and everything is ready. So now I need servers because I am anticipating a lot of user load in the production. So I need to deploy my application. So where to deploy? Either I can set up my own data center or I can use the cloud. So let's say I went to the cloud. This is the way to use the cloud. They have given us this management console. This is called management console. I have just logged into AWS management console. And if you need the servers, we can log into this console. And there are ways, there are services here that I can go, like EC2. If I want the server, so I can go to EC2 and I can create some servers and I can deploy my applications. If I need some storage, like say Netflix, for example, because Netflix is having so much of storage. Netflix uses AWS, okay, for the storage. Netflix primarily uses S3. If you look at the storage service, so all the media content that we watch, Hotstar, Netflix, Amazon Prime Videos, Dropbox, what those applications use AWS S3. S3 is the storage service, simple storage service. That's the full form. So we use these services. The cloud has these services So for the storage, so if I need, let's say, 1 TB or 10 TB or 1 petabyte of storage, I'll use this. I'll go to the console and I'll go to S3 and I'll create some bucket and I'll upload my files. And then I will make sure that users can access these contents. So we have a UI that Netflix the entire thing. So I can in UI, users can log in. I'll put some authentication, right? And user could log in. But eventually, when the user would click on a movie, it will come and hit this S3 content. That's where the content is being placed. So that's how the architecture works. So similarly to this, like EC2, I talked about the server. S3, I talked about the storage. Similarly for database services, we have in the cloud database services. So if you see the database, we have got a lot of services. So not just RDS. RDS stands for Relational Database Service. We have a lot of NoSQL databases as well. We have Document DB, which is like a MongoDB, right? DynamoDB, uh, key value pair. If you want to store data, record the key value pair, you can use DynamoDB. Elastic Cache, want to use the cache, you can use Elastic Cache to increase the performance. We use cache, right? We have key spaces, like which is like a Cassandra. So we have multiple options here, and these are called managed services, database managed services. So how does it differ? So all this time, how we were deploying things? May I ask this forum, what all databases you we have been working, or in your architecture wherever you work, what all databases you have worked upon? Could you just message that in the chat? I'll just get a sense. Okay, I'm waiting. Okay. Siva Kumari has used Oracle 12c. Perfect. How about others? Yeah, if you have not used, guys, you can say no experience. Perfectly fine. If you are a fresher or not into databases, mention a no DB experience. That's perfectly fine. Okay. So good that I started from scratch, cloud and on-premise, because there are looks like people with no experience as well. I see. Quite a few people with no experience. That's perfectly fine. See, so why we use database, guys? See, only one thing, right? uh, we want to store data. Earlier, if you go to bank, right, let's say if you go visit any bank 10 years back, 15 years back, they used to maintain a register. If you want to do an FD, RD, you will go to bank and they will open a register and they will mention, okay, your name, you are depositing this amount. Those were the things we started. Then we started doing in the Excel sheet. We can do that in the Excel sheet. When the computer came and became popular, we started to do the same kind of storing things in a Excel sheet. But when the enterprise level, it's not possible to work. So for manual things, for small little application, Excel thing would work. But for enterprise level application where you have, think about Flipkart, right? So many users they would have. Think about it. So many products they would have. Is it possible? How, yeah, and we go and search. We go to the website flipkart.com and search. First of all, we log in. How we are able to log in? So when we log in, our username and password are getting stored somewhere. Correct? I'm explaining this for people with no cloud database experience. Okay, for that. If you know already, yeah. So just understand that I'm talking from basics. So if you go, let's say why we use database, I'm just explaining the basics. So see, to even to store the credentials, user credentials, username and password, too many people. Think about Flipkart.com. How many people would have created their account? Maybe in crores, 10 crores, 15 crores, or 50 crores, 20 crores, 30 crores people. Is it possible to manage all those credentials in an Excel sheet? We go to the website, we could sign in, we could use our username and password. Is it possible to maintain those in Excel sheet? So no. So those username credentials are being saved in a database with authentication. If you don't give the right credentials, you will not be able to log in also. So that has the authentication also. We need database to store records. Even they have so many products, right? How they you can store products without database? There are so many products they are storing. So database is mostly used for the think about the when you join a company, think about how they would know all the employee details. We get our user id, we get our employee id, we uh, we get all the details. How is it possible? It's not possible without database, right? All our data, all our credentials when we join a company, our username, email address, or user ID, which department we belong, what's the skill set we have, all those details, region we have, our locations, the all these things being stored in the database. So that's the basic use of a database. Now, when it comes to how we store records, either it could be relational or NoSQL, non-relational. I'll give you a simple example. Okay. So when it comes to employee, when I mentioned right that it's not possible, ideally possible to just uh, get away with relational. No, relational will be always used. There will be always the use cases of using a relational DB. See, think about it, right? So let's say employee table of any organization. What let's say there is an employee table. Obviously, there will be an employee table in any organization. And what are the this is the table? What would be the columns here? Obviously, name, first name, second name, last name, second name, last name, whatever. Let's say the email address, employee ID. Yes or no? Location, skill sets, age, date of birth, skills. See, this detail has to be there within every organization. So how we storing records? Let's say any people who join, I will just create some entry for them in a database. And whenever I need to get with some records, I would use select queries. Let's say I use phone number. Absolutely, yes, Sukanya. Phone number. So the point is this, right? That I'm storing some records in a structured way. Do you think it's structure here? That all the records I'm storing in a proper structure way. If I'm adding anybody here in this list, it's going to be structured way. All the fixed schema is there. Do we see that fixed schema for every row that I'm adding? Let's say Syam had joined, uh, Kumar, or whatever. Let's say John, whatever email address. So it's a structure way. Do we see that it's a fixed schema that we are storing records here? All the records are mandatory to have these fields, and we have fixed schema. When I say fixed schema, fixed structure, the way we are storing the records. Do we see that, everybody? I'm asking particularly with no database experience. Guys, please acknowledge. Others would be finding it repetitive, or they would know all this already. Yes? Do we see a fixed schema? Yes or no? Guys, please confirm so that I can proceed. Good. So now I'll give you, so this is called for storing these kind of records. We use relational database. Relational database we call it. So if you take an example of relational database, so Oracle, MySQL, Postgres, right? They are popular, MariaDB. They are very popular databases in this space. Relational database. But now I'll really give example. Everybody has used the phone, right? Here. Now tell me one thing. When the way you store at least the fields, let's talk about the fields. Okay. When you add a contact in your mobile, how many fields do we see that? many fields. We may be using mostly first name and the phone number, but there are so many fields that you can fill. Check your mobile. Yes or no?
Yeah, yes.
Right? So, do you think that there is a fixed schema there? What we follow, forget about it. We mostly use name and phone number, first name and phone number, mobile number. Mostly we use this, but we have columns of writing work locations, date of birth, company they work. We have so many email address. We have so many fields. We skip it. That's another thing. But here the way we can store. Here we have to follow this schema. If we are adding a record here, we have to give full value. If we are skipping few value, we need to put null. If we don't know, we have to put null. But we have to fill some data in every field. But in case of mobile, the way we store records, it's not a fixed schema. For most of the people, we use first name and the mobile number, whatever it is. But we have options that I can use some other contact. I can use Siam, I can use contact number, I can use which company they work, right? Which company they work, what is the date of birth, what's the location. I can give that. So there is no fixed schema here. Do we see this? There is no fixed schema. One record I'm storing like this, other record I'm storing like this, more values, more columns I'm filling. There's no fixed schema. So when there is no fixed schema, we need non-relational databases. So we have non-relational databases as well. In We have a lot of examples, right? We have MongoDB. In MongoDB, we store like in JSON. JSON, one for one record, one JSON file. We have DynamoDB, we have Cassandra. We have a lot of other examples here. DynamoDB, we have Cassandra. So these are the popular examples of using non-relational databases, right? So this is the basic. Okay. So now, how about installation? So either we can, okay, I'm going to ask this question to those who are using it. So those who answered, right? Somebody using Oracle 12c, somebody using Postgres, right? Somebody. So how are you guys using it? Are you installing the database, or are you using a managed service? So we'll talk about that. What for others? What do you mean by in self-managed and fully managed? We'll talk about that. But please answer, Siva Kumari and Krishna and ASNR, Postgres, and you guys are using Oracle. So how you guys are using it? Are you using a installing in a server? Somebody, I'm not sure. Go ahead. Please come again.
Processing and installing already. Did you?
Voice is going. I'm not able to hear you. Can you type it? Your others. How about others? Self-managed. Are you installing it or using a fully managed database, cloud database? Guys, I'm waiting for some answers. Those who are working from them.
Oh, we are
Okay.
using I am using Cassandra, so we are installing the like application directly, and we
Okay. So
can
you are
use the.
installing. So you have a server and you are installing the database on the server, right? So it's a self-managed. You are managing it, right?
Uh,
Okay. ASN are using fully managed. So we'll talk about what is self-managed and fully managed. Let's understand that first, and then we'll talk about reliability. Okay. So when so we have got. I'll talk about three things. Okay. So three things. Let me share you my slide. So we'll talk about three things. This is the roles and responsibility of a So why do we select a managed database? So let me talk about that. Why to select a managed and what is managed? So this is the roles and responsibility of a DBA in on-premise. So remember on-premise, you own everything, or the customer or the company where you're working owns everything. So it is the so this is look at the roles and responsibility of a DBA in an on-premise setup. So the guy has to do all the work, right? So it has to do rack and stack, like virtualization I'm talking about here, server maintenance, install the OS patches, and yeah, it has to install DB. It has to do take care of backups, database backups. It has to do a lot of things about high availability, because if a database goes down, you will have a downtime. So you need to make sure that even if a database is down, your application is not down, right? So high availability is very important, right? Think about it, right? So let's say if you're using one database, if Flipkart.com is down, would you like it? How much business loss they would have if Amazon.com is down because of database is down? How much business loss of revenue, reputation, how much they would suffer? So you have to take care of high availability on its own. The guy has to take care of its own because it's a on-premise thing. Scaling up, so in the production when there are more user load, so it has to scaled up based on, or storage when the things are getting stored, at least the storage needs to be auto scaled because we are storing records. So at least storage needs to be auto scale, but it has to take care of its own. You have this guy has to do its either automation script or manually scaling up. The guy has to take care. So this is all, and obviously the app optimization. If a SQL query is not performing well, he has to work on the SQL tuning and database performance. So this is the roles and responsibility in an on-premise setup. Now think about it. If the same guy would use a cloud, AWS or GCP or Azure, till OS patches, at least OS installation, these work can be till OS installation. This work would be managed by the cloud because they own the data center, right? The AWS owns the data center, so they would do all these things. OS installation, till OS installation, they would take care. And now you can see the guys smiling a bit, right? Breathing, right? Because all this work is taken care by the AWS. Now this guy can focus on these activities, but still a lot. OS patches for vulnerability. This is called self-managed, by the way. On-premise is also self-managed. This setup is also called self-managed. If you're getting a server, just a server from the cloud, and you are installing, or whoever, even if for the performance engineers, right? We need to install some. Many performance engineers set up their own infrastructure in the company. Depends again on the company and roles and responsibility. They set up their own performance environment. So if you get a server from the cloud and you take care of everything, so you need to take care of all these activities: OS patches for security patches, or DB software. You need to install the DB software patches, backups, high availability, scaling up, and app optimization, tuning. So this is called self-managed. This is also called self-managed. So a lot of responsibility. But when we go into managed, so remember I talked about a managed. So I showed you about this. These are called managed services. What happens in managed services? The installations, DB patches, scaling, all these activities will be taken care by the cloud service provider. For example, many of you are working on a relational database, Oracle, MySQL, or Postgres. I can go to RDS, Relational Database Service. I can go to RDS here and I can create a database. See, I'm not going to install it. I'm going to just select options. I'm going to just select some options, create database. I mean, I'm literally creating a database. I can create any one of these database Aurora, MySQL, Postgre, Oracle, MariaDB, IBM DB2, Microsoft SQL Server. This is also the example of an RDS, relational database. I can select Oracle, MySQL, anything here. Let's say Oracle. I can select the version of Oracle, Enterprise Edition or Standard Edition. I think somebody is using 12C here. I do have an option of selecting a version here. I can select a version here. It's all about managed. This is called fully managed. I'm going to select the options. I want Enterprise Edition or I want Standard Edition. I'll select the version. This is for the production environment. High availability. So what I mean, when you use these managed services, these activities, all these activities will be taken care by the cloud service provider. OS installation, what till OS installation, even if you use self-managed, till OS installation was taken care by the cloud. But when you use fully managed OS patches, DB installs, DB software patches, database backups, you don't need to worry about backups. Cloud will take care. High availability, you don't need to worry about high availability. The cloud service provider will take care. The scaling, the storage, scaling of those things will be taken care by the cloud service. All you need to worry, all you need to focus on the app optimization, SQL tuning. That's all. You need to understand which query is consuming more time, how to tune the database, how to tune the query. That's all you need to focus. Everything else, the infrastructure details, everything else is taken care by the cloud service provider itself. Think about it. When you use say fully managed service, so much of work, heavy lifting would be done by the cloud service provider, and high availability would be taken care by them. How? It's all about just clicking an option. I'm using RDS here. I want high availability. Look at this option here. I'm using a production setup here. For high, I can give the DB name and all these things here. And for high availability, all I do will select this multi-AG deployment. So automatically, one standby database would be created in another AZ, standby database. So there will be one primary database. When I say high availability, what do I mean? This is what I mean by the high availability. So I will have a primary database. This is the primary database in one of the AZs. Do we understand AZ? Everybody? Yes or no? Feel free. There may be people who may not know cloud. Do we understand what is an AZ? Everybody understands? Yes or no? Please, quick, guys. It will
For
help me.
cloud, so the commander using non-RDBMS and relational database management, and it is also using for RDMS also, right?
Come again. I could not understand your question. Can you come again?
Okay, so uh, like cloud, it should be commander RDMS, like relational database management and non-relational database management also, right?
Yeah, yeah, yeah.
It like
We have both the options. Yeah.
and like in cloud database, it should manage the non-DBM like non-RDBMS and
Yes.
RDBMS both they have
Both,
to manage,
both, both. When I say fully managed, I'm not referring to only RDS. I'm talking about all the database options. I'm not talking only about relational. I'm talking about no non-relational as well. Okay, guys, do we understand AZ or not? I'm asking everybody. Yes or no? Please type it, guys. I just any response would be fine. Yes or no, guys. Do we understand AZ? Because if you don't understand, you will not be able to understand high availability. Okay, no, no problem. See, when in the cloud, right? If you look at the cloud architecture, okay, because when you use cloud, how it is, how we use, right? Let's say you have the regions concept, okay, we have a regions. So if you look at this cloud, because see, the cloud data centers is spread across the globe. We have got multiple. If you look at the AWS global infrastructure, these things are must nowadays. Okay, cloud, whatever I'm talking about, right? It's, if you don't know, it's, you are like a fresher. Okay, so these things are must. You should know these things. If you are looking for a career in your IT, you have to know all these things. Find a way to know all these things. Okay. Anyway, I'm going to give you a good start here. So I'm talking about one of the cloud, AWS. So if you look at the infrastructure, cloud infrastructure, AWS, because see, it's for Amazon Web Services, it's a business. They have setting up data centers. They have set up data centers across the globe for their business. I'll tell you one of the quick one good story. So, who is the owner of AWS? Do we know who is the founder of AWS? Jeff Bezos. Do we know that guy? Same founder of Amazon.com, right? So the guy, Amazon.com, this is the founder, Jeff Bezos. Okay, the guy was setting up on premise for Amazon.com 20 years back, 15, 20 years back. 20 years back, the guy was setting up around 2005, 2002, 2003, 4, 5. He was setting up the on premise for Amazon.com website. And while setting up the on premise infrastructure, he got this business idea of AWS. Think about it. So, and he thought whatever he is doing for Amazon.com, he can leverage this for others also. So Jeff Bezos got the brilliant idea. So he is not, so that's why he is the richest. He's Amazon.com and AWS both are the best, right? One in the retail domain and one in the cloud domain and their business. So that for them, it's a business. They have set up these many data centers. So when I say availability zones, AZ, that's nothing but the data center. They have 102 data centers, AWS across the globe, and it's present 32 launch regions. In India, they have two regions. One region is in Mumbai, and another region is in Hyderabad. And in one region, usually there are three AZs. Three AZs. If you look at this, so this is the globe. Uh, can you read this? How many AZs they have in Mumbai? Three. Can we read this, guys? Everybody? And in Hyderabad also three. So usually in one region they have three AZs. Why do they have three AZs in one region? For that also it's a logic. So think about it, right? So in one region, let's say in Mumbai region, so they have got three AZs. One in AZ1, AZ2, AZ3. Why do they have three AZs in one region? Why not one? Why they have multiple? That's a good question to understand. Again, for high availability, guys. So for any application, the high availability, performance, security, these are the top concerns for any website that we use. What are the top concerns? High availability. The application should be highly available. You like any application which is going down very frequently? Answer is no. Would you like any application which is not performing well? Answer is no. Even any application, Uber, Ola, Swiggy, Blinkit, Jepto, whatever we use in daily life, Make My Trip, we don't want to compromise on these things. As a user, that's the expectation. Security, again, if you're storing our credit card details, user details, it has to be secure. Right? So these are top concerns. So one of the top concerns is the availability, high availability. How to make highly available? So to achieve high availability, the idea here is to have redundancy. So think about it. If you have only one server deployed in one of the AZs, one of the data centers. So when I say AZs, consider a data center. and they have three AZs in one region, in Mumbai region. I'm showing you a Mumbai region. I'm talking about a Mumbai region. They have got three AZs. Why? Think about it. Answer my question. If you have only one server in your complete architecture, and if that server goes down, would you experience downtime? Yes or no? Absolutely yes, right? One server is there and it's down. So to avoid that, what is the idea? Have multiple servers in one AZ. Create multiple servers. Don't create one server. Have multiple servers. Avoid single point of failure. That's the mantra number one. We should always avoid single point of failure. We should always have at least two servers for web server, application server, database server, whatever it is. At least we should have two servers, because even if one server goes down, we have other server. We will not have a downtime for any architecture in any application. Then fine. Then you can ask, right? Then if we have two AZs, two servers in one AZ, then why they have another AZ? What if the flood came? Think about it. In one of the AZs in Mumbai region, they are located approximately the distance would be around 150 to 200 kilometers apart. They are not close. They are not in a very nearby distance. They are at some distance. If you by one of the principle is that at least they should have 150 to 250 kilometers apart. They have to be this distance apart. Because if this flood came in this region, again, when the flood came, earthquake came, natural calamity happened, and if you have if you're deploying only one AZ, would you get downtime? Yes. So how to avoid it? Create Have your servers deployed in another AZ also. So if you look at the AWS architecture also, they are incorrect. They understand this, and that's why they have set up data centers like this in per region, multiple AZs per region. And then you can have a load balancer, and your request, let's say you hit amazon.com or flipkart.com, your request would be redirected to these servers from the load balancers. All these servers, the request would be redirected. And then you have auto scaling and all these things. You have all those things you have, so that if the user increases, you can server should also increase automatically. Okay. Do we? I hope you understood this part. Everybody, could you acknowledge why why do we have multiple AZs in a region, and what's the thought process behind high availability? Right. That's how it is. Right. So I'll go back to my this. So think about it. So one of the database, primary database would be in one of the AZs, main database, and their standby database. Because again, if you have only one database, think about it. If you have only one database, and if that goes down for any region, right? It could have any region. If that goes down, you will have a downtime, which is not acceptable. So how to take care of high availability? So have a standby database in another AZ, and data being synchronously replicated. When the need arises that let's say this AZ or this database is down for any region, when I need to switch the traffic, all the data should be present here. So it's synchronous replication happens. Synchronous. Remember this word, between the primary database and the standby database, synchronous replication has to happen. If it will not be synchronous, then it will not serve the purpose. Because if this database goes down, and if I had to switch the traffic, all the data should be present. This will be my primary now. This will be my main. This will become my secondary. Right? That's how it works. So, and high availability, you don't need to worry when you use managed database. Think about it. If you use, a lot of people are using self-managed here. Are they taking care of HA? High, are they creating standard database? You can ask this question to yourself. If you're not creating a standard database, it's a risk of you going observing a downtime. And if you use a managed database, this will be taken care by the cloud itself by just click of an option. All I will do is just check this option. Create a standard database. Automatically it will be created. I don't need to worry about it. So I will give all the options, automatic storage auto scaling also. I can mention storage will be automatically scaled from 110 GB to 65 TB. Automatically scaled. I will give all the options. I will select the machine type also. If I need some data, performance insights, some monitoring, I will just check this box and I will get beautiful graphs also. All the performance related graphs, read per second, read latency, write latency, CPU, memory, all the things I will get in one graph. And I will just click on create database. I will just select the options and I will create the database. That's all. And it will take 10 to 15 minutes and my database would be ready. High availability, auto scaling, taken care. This is the fully managed database. And this is what it brings to the table. It brings high availability. It's a managed. So AWS guarantees its availability. You don't need to worry about it. But if you use EC2, a server, and you install your own database, you have to take care of its availability. You have to configure its auto scaling. You have to configure its high availability. Everything you have to take care. But when you use managed services, think data, the cloud will take care of all these things. Are we understanding things? Self-managed and fully managed. Yes? No? Any questions? I will show this, create this later. I need to touch base on few more things. We have got 10 minutes. Is it making sense to all of you? Please give me a thumbs up or yes, no. Any question, please unmute yourself and ask. Okay, good. I got one thumbs up from Livingston. How about others? Not far following? Okay, Sukanya, thank you. Two people have understood, others nodding their head. We cannot see your head. Okay, thank you so much. Let me explain the last part. How about the performance? Right? I talked about high availability. Right? I talked about there are three things, three important things. Security. For the fully managed service, the encryption will be taken care by the cloud. The data at rest and data in transit. The encryption will be taken care by the cloud service provider itself. Then how about the performance? How about if my user load is increasing and lot of reads are happening? See, in a database, what happens? We need to understand this. In a database, what happens? Let's say you have a database. What happens? Either you read data or you write data. That's all the two activities happens. Either you will write data through insert query, write operations. Either you write operations happens by insert query or update query, SQL query I'm talking about, or delete query. Either write operations happens, and for the write operations, three things happens, or mostly the read operations happen. Select queries. The other two operations happens at the database level, and the performance gets choked because of these activities. If too many select queries, if too many these services, all these four, these three and one, four, if too many such services are happening at the same time by a lot of users, the performance degrades. So what is the option? And mostly This we cannot control. We have to do this in the primary database because this is the write happening and the primary database has to get updated. Then only it will replicate to the standby database. There is no other option. So, and this will be comparatively, this will be this you cannot change it. You have to update the primary database because it's a write operation. But for the read queries, a lot of read queries, what we can do, we can create one more type of database because it's a read operation, right? We will create read replicas. We have a concept of read replicas. In fully managed database, we have a concept of read replicas. Read replicas. We will create read replicas. What will happen to read replicas? The reads we will mention, don't go to the primary database, main database. Don't, for the read operations, hit, don't do the select query from this. We will create one read by read replicas like this. From this main database, we will create one read replica and we will ask all the read queries to go to this. And this will be asynchronous replicated. Asynchronous, it's a read operation, can be bit delayed, asynchronous. Read replicas. So we'll create that so that at least the read operations. And let's say if I want to generate a report and I need to fetch a lot of data. So there will be a lot of select queries. And if you hit all the select queries to the Param database, it may slow down the performance. So we will create a read replica. And for those kind of reporting things, we will do the select queries in the read replicas. So at least the traffic, the load on the main database can be reduced. Yes or no? That's the concept of read replicas. And let me show you in the architecture diagram. So this is the concept of read replicas. This is what we do. So we have a prime database and asynchronous replication. We'll create read replicas and read could be at least not all, at least for the reporting or these kind of activities. For reporting where all the select queries will hit and slow my application, I would in the architecture I'll make some changes and I will do the read things from this database so that the load on the prime database could be reduced. So I have taken care of all these three activities in the fully managed database. Making sense? To some extent, guys. Yeah, I'm feeling
Yes.
that yeah, perfect. That's good. That's good to know. See, guys, for others, right? I'm coming up with a course, guys. Okay, I'm coming up with a course where I talk about a lot of these things from scratch. Okay, so I have a course starting from tomorrow, and if you go to this link, I'll give you this link, and I will ask one of my team members from ISA to share you this link of the group where others have enrolled already, have joined this group. Tomorrow is the demo session, and in this course, I will talk about cloud, Linux, Docker, Kubernetes, SRE, Terraform, Ansible, a lot of things, Jenkins. So I would like you to go over this syllabus, go over the reviews that I have been getting from my learners, and the syllabus of the course. It's AWS. Whatever I just talked about was just a demo, and we take it from scratch. Okay, I know where are we, so we take it from scratch. So this course talks about the cloud. This course talks about the Linux. Linux is a mandatory thing, okay, because all the enterprise applications are installed on Linux, not on Windows. So if you're comfortable with Windows, how to open a directory, open a file, searching for a text in a file, Control F. But if I ask you to do the same operations in Linux, many of you would struggle because not many of you would have the experience working on Linux. So I understand the problem statement and the issues. So we have this course on the Linux, on this. So cloud, Linux, SRE concepts. What are these terminologies mean? High availability, disaster recovery, fault tolerance. What is SLIs, SLO, SLAs? We'll talk about monolithic and microservice architectures, containers, Docker, Kubernetes, right? If you look at this, very popular. If you go to any interview nowadays, if you're a 6 plus, 5 plus experience, Docker and Kubernetes microservices have become indispensable. It's important, like a basic thing. If you say that you don't know what is microservices, you don't know Docker, it's very difficult to crack that interview. This has become very common things. I hope you all would agree, right? uh, the performance engineering in DevOps, how performance engineering fits in DevOps. We'll talk about CI/CD pipeline, how to automate your Jmeter script using Jenkins. We'll talk about that. We have how to gain resiliency and reliability on AWS. Observability, we'll talk about Linux monitoring, CloudWatch, Prometheus and Grafana, and ELK. Observability part. Troubleshooting, applications using Java, thread dump, heap dump, database performance. We'll talk about that. Scripting, using Terraform and Ansible. So it's a full on course. Okay, it's a full-on course, completely course, good for the performance engineers and aspiring SRE engineers. So go over this link, join the demo, take couple of demos. We have sessions planned, understand and take a decision. But learn this. That's my objective, and that should be the takeaway. That somebody told you to learn these things. Either you join this course or you learn by yourself. Absolutely fine. But you learn this if you want to grow in your career. Okay. So I'm gonna share this link. So takeaway should be you should know all these topics if you want to progress in your career. Anyhow, so this is a link, guys. I hope everybody has got the link, and I'll ask one of my team members to share you the group link to join uh, the demo session of tomorrow. Sounds good, everybody?
Good, good.
Any questions on the topic that we discussed? Okay, guys, so that's all I wanted to cover today, guys. I'll I have this. We do this demo on the regular sessions that we have. I've just given you a brief about the workshop. I hope you learned something out of it, and looking forward to meet you all. Thank you so much, everybody.
Thank you, Roshan.
Okay.